the classes and this class will be mostly in the English medium। और हमें पता है कि इस मीडियम में जो है कई लोगों को जो है शायद उतना सहजता एहसास ना हो, लेकिन कुछ लोग जो है चाहते ही हैं कि इस तरह का मीडियम का कोई तो हो जो इस तरह से पढ़ा करके हमें दे दे। तो देखिए, भाषाओं का कोई दिक्कत जो है आपके पास नहीं होना चाहिए, मेरे पास तो नहीं ही है, ठीक है, आपके पास भी नहीं होना चाहिए जो, ठीक है। एटलीस्ट आपको इंग्लिश और हिंदी मीडियम पे तो बहुत अच्छा से पकड़ होना ही होना चाहिए जो, ठीक है। और ऐसे भी आपको मालूम है कि कुछ एग्जाम्स में आपका जो है भाषाओं का भी टेस्ट जो है आपका किया जाता है, ठीक है। तो आपको भाषाओं पे पकड़ होना ही होना चाहिए। कई लोग को होगा कि जिन्हें थोड़ा सा इंग्लिश वाले मीडियम में हम अभी जब बताते रहेंगे, ठीक है, जब हम क्लास के मूड में पूरी तरह से आ जाएंगे और जब आपको इंग्लिश वाले मीडियम में बताते रहेंगे तो कई लोग को जो थोड़ा असहजता जो है हो सकता है और कई लोग को बहुत अच्छा भी लगेगा। तो देखिए, आज का जो क्लास रहेगा, हम आपको शुरू में ही बोले थे कि हम आपको आज का क्लास को जो है वो हम इंग्लिश मीडियम में रखे रहेंगे। जो हम ये जानते हुए कि कई सारे लोग जो है हिंदी मीडियम के रहते हैं, लेकिन आज का क्लास हम इंग्लिश मीडियम में रखे रहेंगे। इससे आप पूरे भरोसे में चले आते हैं कि यदि हमको हिंदी में पढ़ाना है तो हम हिंदी में बहुत अच्छी तरह से पढ़ाएंगे, इंग्लिश से पढ़ाना है तो हम इंग्लिश में भी पढ़ाएंगे, बाकी जरूरत पड़ा तो भोजपुरी और मगही से भी परहेज नहीं रहता है, ठीक है। तो टुडे आवर क्लास विल कंटेन द डिस्कशंस, और ये आप देख सकते हैं कि ये हम आपको एकदम अपने हाथों से जो है ये स्लाइड्स को बनाए, एकदम बहुत मन से, एकदम जिसको बोलते हैं ना अपने घर के हाथों का रोटी बना हुआ ना, खाना बना हुआ ना, उसका एक अलग फीलिंग रहता है। वैसे ये आपका जो स्लाइड्स बना हुआ है ये हम अपने हाथों से बनाए हुए, एकदम अलग से, एकदम समय मिलने के बाद बहुत ढंग से डिजाइन कर देते हैं, ठीक है। सो द क्वेश्चंस विल कंटेन some parts of the Hindi language, but in this session, today's this session, I will continue most of the time speaking English, explaining in the English language. So you have to accommodate with that. Our first question on the screen is that the energy of an X-ray photon of wavelength 1 angstrom is. We know that energy of photon can be given by h nu. It can be also given in terms of the lambda wavelength. Energy of photon or energy of light can be given by this formula, E is equal to h nu or E is equal to hc beta lambda, where c is the speed of light that can be considered as 3 into 10 to the power 8 meter per second. H is the Planck's constant, where you have to know that this value can be given as 6.62 into 10 to the power minus 34 joule second. This value you are expected to know that. Sometimes it may be given in the questions, sometimes it may not be given in the questions. Here it is given in the questions. If it is given, then it's all well. Even if you are in confusing a state, sometimes we get confused in the constant, then it will help you. Otherwise, you will have to lose that questions and the corresponding marks due to that value. So energy associated with any light or photon can be given by this. So if you put this value and going to calculate, it will take time. 1 angstrom means what? 1 angstrom means 1 into 10 to the power minus 10 meter. If you are going to put this value and go to calculations, you will take time, and in exam time is also important. You have to solve the question correctly with least possible time, So as a trick you should know, and I expect many of you must be knowing that trick also, but few of them or mostly you are not aware of that. So we can give the energy of photon or light as 12,400 or by lambda, where lambda should be in the angstrom, and it will directly convert this energy in the form of electron volt. You must be aware that we express energy of light, we express energy associated with the electrons, protons, neutrons, or any atoms or molecules or nucleus or nuclear particles, nucleons, in the terms of electron volt. Indeed, the standard unit of energy is joule, but in case of the atomic or subatomic particles or nuclear particles, we express energy in the terms of what? In the terms of electron volt. You must be knowing are aware that 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. By this, you can transform any value of joule into the electron volt, or if it is given in the electron volt and you are expected to calculate in the joule, then you can use this formula. So using this trick, what we can know, it is given that 1 angstrom wavelength is given associated with the light. If you are going to put this value 12,400 by 1 into 10 to the power what? Minus 10. Should we put this? No, because we have already told you that lambda should be given in the terms of angstrom. So you need to give the digit or value that is given in the questions in terms of the angstrom. You don't need to calculate this much, because if you put this, you will get the answer in the terms of joule. But if you have to get the answer in terms of the electron volt, then you have to put this, and you must use here the value 1 angstrom means 1. So it is what? It is all about 1.24 into 1.24 you can say into 10 to the power what? 2 10 to the power 4. So is it given in the questions like that? No, it is not given in the questions. It is wrong, it is wrong, it is wrong, it is wrong. So here none of the above. And what should be the value? The value should be this. What should be the value? The value should be this 1.24, and to accompany that you have to put 10 to the power 4. So answer should be like that. Answer should be like that, and it is not given in the questions, and you have the option like none of the above, then you should go for the none of the above. Otherwise, if you have to give the value, then you can say this much value will be the energy associated with the photons or light having the wavelength of 1 angstrom. Okay. Now, our second question is, it is impossible to know simultaneously the position and momentum of moving particle with absolute exactness at any instant. This is known as Heisenberg's uncertainty principle. Heisenberg uncertainty principle, this is the statement that if you are going to calculate the position of any quantum particles exactly, then you will have to lose the accuracy in the measurement of momentum anyhow. It is not the problem of the instrument, it is not the problem in the measurement, it is not in the problem of the machine, it is the restriction of the nature. It is the restriction of the nature. Even if you have the best mind that can measure, if you have the best instrument that can be used, if you have the best calculations that can be applied, even then if you are going to calculate the position exactly, you will lose the accuracy in the momentum. This uncertainty can be expressed in the form like this. If you are going to calculate the accuracy with positions, then you will lose the accuracy in the momentum, and this will be minimum h by 2 pi. This will be minimum h by 2 pi. H by 2 pi. Delta x delta p is greater than or equal to h by 2 pi. In some book they are also can be given by h by 4 pi. H by 4 pi. Earlier, if you read historically, then you will find that earlier Heisenberg give this, even this was not given by the this value was not given by the Heisen. Heisen has told that this will be greater than or equal to h, but later when we calculated, then we calculated h by 2 pi, and after that we have just calculated that it will be the h by 4 pi. So this uncertainty is also associated with the angular momentum and angular position. This uncertainty is also introduced in energy and time. So what is the rule of this? What is the rule of this? You can give the rule as Heisenberg uncertainty principle. This is the Heisenberg uncertainty principle. This is the Heisenberg uncertainty principle. We expect you all to share the classes. We expect you all to share the classes. We expect you all to share the classes, We expect you all to share the classes. So this is the uncertainty principle. Now the question arises, sir, you have told that earlier Heisen has taken this value, this was refined by h by 2 pi, this was refined as h by 4 pi. Then which value should we take in the examination? You should take this value. You should take this value. So we can give what? We can give the uncertainty principle delta x delta p is greater than or equal to h by 4 pi. Delta theta delta L is greater than or equal to h by 4 pi, or delta E delta T is greater than or equal to h by 5. In history, we always come across to the point that sometimes exact value is not known, and after that doing a various experiments, we move towards the exact value. So we should take h by 4 pi, and h by 4 pi can be also written as h cross by 2. It is h cross by 2. Sir, what is this? Sometimes you are telling that it is h by 2 pi. Now you are confirming that h by 4 pi. Then why you have written h cross by 2? H cross is a symbol. It's not a writing style. It is a symbol for h by 2 pi. It is a symbol for h by 2 pi. H by 2 pi, it is symbol for what? H by 2 pi. So if you put the value of h cross as h by 2 pi, then you will get this h by 4 pi. And you should finalize the value while using the uncertainty principle. In 2 days, you have to take h by 4 pi. It means the minimum inaccuracy you must accept. The minimum inaccuracy you must accept is h by 4 pi. Whatever the instrument be, whoever the measurement is going to do, whatever the methods you are involving, you will get the error surely. And it is the restriction of the nature. It is not restriction of the physics, calculation or measurement on any experimental person. It is the nature restrictions. So Heisenberg uncertainty principle. This comes in the 3 form. The most popular form is indeed this form. After Heisenberg, when we solved the Schrodinger equations and use the commutation rule, what you have heard, commutation rule, then you will know about the pairs that has uncertainty. When you are using the commutation rules in the quantum physics, you will know which pair will follow the uncertainty principle or which pair will not follow. It is not only that only these 3 pairs follow the uncertainty principle. No, not at all. There are so many pairs you can't measure with 100% accuracy. You have to accept the restriction of the nature. So Heisenberg uncertainty principle, Aufbau principle. It's in electronic configuration, you arrange the electrons like this in the form of energy label: 1s, 2s, 2p, 3s, 3p, 3d, etc. 4s, 4p, 4d, 4f. As energy label, you just what do? First, you fill the 1s orbital. In the next step, you fill 2s orbital. In the next step, you fill 2p orbital, and then you have to fill 3s. And after that, you go to this sequence. This sequence is known as Aufbau principle. What is Hund's rule? It's for maximum multiplicity. Maximum multiplicity. First, you have to fill the values, and thereafter you have to what to do? Then you have to do this. You have to do this pairing. So this is the Hund's rule. And Pauli's exclusion principle tells that no electrons in a given orbital will have the same quantum number. It gives the uniqueness or exclusion that if in orbital one electron is filled with up spin, then another electron will be filled in the down spin. This is the Pauli's exclusion principle. So we have discussed shortly of Bauer's principle, Hund's rule of maximum multiplicity, Heisenberg's this was not Heisenberg of the wavefront theory. This is Werner Heisenberg's principle. This is uncertainty theory. This is known as Heisenberg's uncertainty theory, and this is the Pauli's exclusion principle. So we have just known the history. First, h was given. After that, h by 2 pi was given, and now we have accepted that it must be more precisely it must be h by 4 pi. More precisely, it must be h by 4 pi. हाँ, एक सिद्धांत कुमार है, माधरचोद सिद्धांत कुमार, जो बोल रहे हैं कंटेंट जो है झाट भर, तुम्हारे बाप का झाट, तुम्हारी माई का झाट, तुम्हारा बहन का झाट, ठीक है। तुझे कर भेजल होगा उससे कोई दिक्कत नहीं है, ठीक है। तुझे कर भेजल होगा उससे कोई दिक्कत नहीं। सिद्धांत कुमार जो जाकर के माई चुदाव जो, ठीक है, जो जेकर भेजल है ओकरा से जाकर के माई चुदाव जाकर के, ठीक है। बाकी लोग थोड़ा स्थिर रहते हैं, बाकी लोग थोड़ा स्थिर रहते हैं। इस सिद्धांत माधरचोद को जो भेजा हुआ है किसी न किसी झाट कुमार का, किसी न किसी कोल्ड स्टोर का ये भेजा हुआ मादरचोद है, इसको बाहर कर दिया जा रहा है। आराम से रहिए, पहले इस मादरचोद को बाहर कर दिया जा रहा है, इस मादरचोद को पहले बाहर कर दिया जा रहा है, ठीक है। चलो मादरचोद, चलो निकल जाओ यहां से तुम, ठीक है। चलो ये सिद्धांत कुमार मादरचोद बाहर निकल गए। चलिए आप लोग कोई हड़बड़ाइए नहीं, जब हम एकदम कूल रहते हैं, एकदम कूल, जो एकदम कूल, ठीक है। चलिए सिद्धांत कुमार मादरचोद जो है किसी कोल्ड स्टोर का भेजा हुआ, किसी टीचर्स का भेजा हुआ जो है, ठीक है, था, इसलिए जो है इधर उधर का बात कर रहा था, तो उसको पता नहीं था कि यहाँ पे टीचर जो है किस तरह का है। सो बी कूल, आई एम फाइन, यू हैव टू आल्सो बी फाइन। सो आवर द नेक्स्ट क्वेश्चन इज दैट, in photoelectric effect, the maximum initial velocity of emitted electrons depends upon, the maximum emitted electrons depends upon. You must be knowing that what is the photoelectric effect. Photoelectric effect is the phenomenon of emission of electrons from the surface of metals. What is photoelectric effect? Photoelectric effect is the phenomenon of emission of electrons from the surface of metal due to irradiation, due to use of light. This is called as photoelectric effect. And the electrons that get emitted during the photoelectric effect, they are called as what? Photoelectrons. And the current associated with that photoelectrons is called as photocurrent. Is called as photocurrent. Okay? Is called as photocurrent. So you must be knowing, and I have earlier also told that the photoelectric effect was theoretically explained by the Einstein, for which he was awarded Nobel Prize in 1921. For which he was awarded Nobel Prize in 1921. The kinetic energy associated with, the kinetic energy or maximum kinetic energy of electron associated with that can be given by h nu minus h nu naught. This is work function. This is what? This is work function. This is work function. Is it clear? Is visible? Okay, it is visible. Let me choose the color as white. So this is h nu, energy of light, and minus this is work function, which is the nature of the material. Of what material? The metallic surface on which light has been given. On which light has been given. So h nu naught, h nu naught, h nu naught. Okay? So what we conclude here? We conclude that hc bata lambda naught. Okay? We can write the frequency in terms of the wavelength by using the formula nu is equal to c by lambda. So this is the energy associated with the light you are using for the photoelectric effect, and this is what? This is the minimum energy to let the photoelectric effect start. This is the work function. This is what? Work function. This is work function. Work function is what? It is the minimum energy required for letting photoelectrons to get out of the metallic surface. The minimum energy it is. The minimum energy it is. Okay. Let me continue and let me move. Let me move. I know for the English, for the Hindi medium students, this is a little bit difficult to just get into the understanding for the Hindi medium students. But don't worry. Don't worry. In our next classes, we will be using what? We will be using the mixed language, Hindi or English language, your favorite bilingual format. We will use this. But today's class, I have already told you that this lecture will be contained in the English medium. बस कुछ माधरचोद जो अपना आते हैं तो उसको उसी तरह सुनाना था, ठीक है। जो ट्रॉलर कुछ लोग आए थे, जो भेजा हुआ है तो सुन लो। जो ट्रॉलर था, स्टूडेंट तो ऐसा करते ही नहीं है, स्टूडेंट थोड़ी ना बोलेंगे आकर के, जो ठीक है, स्टूडेंट तो पढ़ते हैं या तो नहीं पढ़ते हैं। ये कुछ माधरचोद जो लोग है ना, वही लोग इधर उधर जो है करते हैं। तो सुन लो, वो माधरचोद जो है, मालूम चल गया, सुधर गए तुम, ठीक है, वरना कब्र के अंदर या शमशान घाट पहुंच जाएगा माधरचोद, ठीक है, जो ट्रॉलर यहाँ पे भेजता है इधर उधर नौटंकी करने वाला, तो सुन लो मादरचोद, ठीक है, सारे का सारा जो है ना पेल देंगे, इतनी तरह के पूरा खानदान जो है पेला जाएगा, ठीक है। इसलिए वो सारे मादरचोद जो यहाँ पे भेजे जाते हैं थोड़ा स्थिर रहते हैं एक तरह से, ठीक है। वो जो था एक, ठीक है, वो कुछ और नहीं, वो किसी का भेजा हुआ नमूना था एक तरह से, ठीक है ना। ऐसे से भी होते रहेंगे, तू पेलाते रहेगा, ठीक है। सो आवर द क्वेश्चन, व्हाट द आवर क्वेश्चन वाज दैट in photoelectric effect the maximum initial velocity, this is the maximum initial velocity, depends upon what? Intensity of the incident light. Intensity of incident light is associated with the number of photons. It is associated with the number of photons. It is not associated with the energy. Energy of photoelectrons depends upon frequency, depends upon wavelength of the light used. Wavelength of the light used. So intensity of incident light is just number of photons increased. If you are increasing the number of photons, then more probability will be the emission for the photoelectrons. Okay, so this is not associated with the velocity, this is not associated with the electrons. Frequency of the incident light, yes. Threshold frequency, the minimum frequency required to start photoelectric effect is called as threshold frequency. Both B and C, yes, both B and C. The best option will be both B and C, because energy of the photoelectrons is associated with the frequency of the light used or the wavelength of the light used. Higher the frequency of the light used, more will be the velocity, and this emission is called, this emission is what? This emission is probabilistic. This is probabilistic. It means what? Not every photons will be successful to get knocked out some electrons. Not every photons will knock out electrons. It may be possible or it may be not be possible. It may be possible that 10 photons struck on the electrons and only one electron were successful to come out from the surface of the metal. Okay. Now our next question is the magnetic moment of an electron circulating in the first orbit of hydrogen atom. What it is saying, the electrons that is revolving, around the nucleus, it behaves like a circulating current, and we already know from the classical mechanics also that a circulating current behaves like magnetic dipole. So these circulating electrons will behave as if some current is flowing in this orbit, and this will behave as if there is some minimum dipole moment, magnetic dipole moment, and that magnetic dipole moment is referred by the Bohr magneton. This Bohr magneton is the minimum value of the magnetic moment that can be possessed by any atoms. Okay. Now our next question is that a material exhibits a spontaneous magnetization. For example, let me tell you that there is something like this. This is a spontaneous magnetization, but this is magnet and this is also magnet. But if we use some kind of, what we can say, we use some types of iron, let it be this iron, and this is the magnet. Then a spontaneous magnetization. What happens? A spontaneous magnetization. So a spontaneous magnetization will occur to the ferromagnetic materials. Magnetically, materials can be categorized in three forms, majorly in the three forms. What is that? Diamagnetic material, paramagnetic material, and ferromagnetic material. Okay? Mainly we can categorize material as diamagnetic material, paramagnetic material, paramagnetic material, and ferromagnetic material, ferromagnetic material. Let me confirm that. If any bastard is now just disturbing the class, let me confirm that. If any bastards or motherfucking students is entering in this classroom, no, that motherchode has been reported and let him kicked out. So let us go smoothly. So what we were telling that any material exhibits a spontaneous magnetization. That means that material is ferromagnetic material. Paramagnetic material, this material has tendency but weaker tendency to go into the magnetic field. Diamagnetic material, this material do not have tendency to go into the magnetic field. This has the repulsive nature towards the magnetic field. This has attractive nature towards the magnetic field, and this has a strong attractive nature for the magnetic field. So this is a spontaneous magnetization. That means that material is what? Ferromagnetic material. That material is ferromagnetic material. Our next question is, the displacement current arises due to. The discussion about the displacement current first was given by the Maxwell's fourth equation, and Maxwell's fourth equation is what? Maxwell's fourth equation. Maxwell's fourth equation is what? Maxwell's fourth equation is that del cross H is equal to JC plus this is JD. This JD is the displacement current. This JD is the displacement current. Displacement current, and this is the conduction current. This is the conduction current. This is the conduction current. Conduction current arises due to the charge carriers. But this displacement current do not need any charge carriers. It can travel even in the vacuum. This do not need any material medium for its propagation. This is displacement current, and this is produced due to variation of displacement vector with respect to the time. This is the electric displacement vector. When there is variation in the electric displacement vector with respect to time, then current will flow. The current will flow, and this current is wireless current. This current is what? Wireless current. We can also give this dou d by dou t as epsilon naught dou E by dou t. Variation of electric field in time varying space will produce what? Will produce this wireless current, or you can say displacement current. Displacement current is wireless current, and this is the beauty of the what? Maxwell's fourth equation, that is modified Ampere's equation. Maxwell's fourth equation is what? Modified Ampere's equations. So does it need flow of electrons? No. Conduction current needs electrons, but displacement current do not need any material medium, do not need any materialistic charge. Flow of holes? No. Flow of both electrons and holes? No. Time varying electric field? Yes, this is the correct answer. Time varying electric field can produce wireless current or displacement current, and this is the result of what? This is the result of Maxwell's fourth equation. So time varying electric field, this is the displacement current, ZD. It is denoted by ZD. Okay. Now, which of the following characteristic is not associated with a laser light? Which of the following characteristic is not associated with a laser light? Which of the following characteristic is not associated with a laser light? Laser light is monochromatic. You should know this. The laser light is monochromatic. The laser light should be monochromatic, and it is monochromatic. Okay. Monochromatic means single wavelength. Whatever the wavelength be, that wavelength will be single. That's why it is monochromatic, highly monochromatic. This is coherent in nature. Laser light is very intense. Even you can observe the laser light in the daytime also. They are intense, monochromatic, coherent, and unidirectional. When you focus the laser, it will go straight forward. Okay. So which of the following characteristic is not associated with the laser light? Coherency, it is associated with the laser light. Brightness, it is more intense, it is associated. Polarization, light, it is a light. Laser light is also a light. Yes, it's that its origin depends upon the transition of atoms or the transition of electrons inside the atoms. It has quantum origin, it has atomic origin, but it is light, it means it is electromagnetic wave. So coherency will be its property, brightness or intensity will be its property, polarization will be its property because it is electromagnetic wave, but it has quantum origin. Double refraction, this is not necessary. So our answer for this question is that which of the following characteristic is not associated? This double refraction is not associated with the laser. Our next question is that Michelson-Morley experiment was performed by. Michelson was a very fantastic, or you can say a brilliant experimentalist. He was a brilliant experimentalist. He has developed interferometry. He has developed interferometry that you study in the Michelson interferometer. But in this case, this question is asking about the relativistic theory. Michelson-Morley experiment was done, and this led to the development of theory of relativity, that was STR, special theory of relativity. What this experiment has proved? This experiment has proved that there is no ether like material. There is no ether, no ether, no ether. Ether, it is not a chemical ether. Earlier days, when we are not aware how light propagates in the space, then we have developed a very amazing, irrelevant concept of ether, a medium that can't be realized, but it is present everywhere, even in the vacuum. It was the earlier thinking. But Michelson-Morley experiment proved that this concept of ether is very foolish, is very needless. It do not need to be considered. There is nothing like ether present in the space, and this is the null result. This is the null result because Michelson-Morley experiment was done to confirm the presence of ether. But Michelson-Morley concluded that there is nothing like that exists in the space, so this concept must be rejected. And from there, Einstein formed his famous postulates that light do not need any material medium for its propagation, and this light has no any relativistic effect. It means what? Whatever be the observer, whatever be the observer speed, whatever be the frame speed, the speed of light will be observed same. It means speed of light is not relativistic. A speed of light is not relativistic. Other any bodies moving with the speed comparable to the speed of light will show relativistic effect. Okay. So the Michelson-Morley experiment led to the null result, or just neglected or rooted out the concept of ether that was earlier carried out absolutely. So to measure precisely the wavelength of sodium light, no. In the interferometer, when you are asked why Michelson interferometer is used, then in case of interferometry, it is possible that you need to calculate the wavelength, you need to calculate the frequency, you need to calculate the refractive index of the medium, you need to calculate the thickness of the medium, transparent medium. But in that case, it will be Michelson interferometer. This is what? Michelson-Morley experiment. Michelson-Morley experiment. So this is wrong. To check whether sodium light is monochromatic, wrong. To calibrate the standard meter, this is wrong. To investigate the possible existence of an ether drift, yes, to investigate. And what he investigated? That the idea of ether is foolish concept. They are irrelevant, they are baseless concept, and they rejected the idea of the ether. And from there, Einstein get inspired about the nature of the light, that speed of light should be independent of the observer, speed of light should be independent of the frame of reference. Okay. And in this case, if you are asked for the Michelson interferometer, this is another question. Michelson interferometer is used for this purpose, for this purpose, for this purpose. But in this question, we are asked about what? Not Michelson interferometer. We are asked for the Michelson-Morley experiment that was carried out to check the existence of the ether. Okay. In an adiabatic process is also known as, adiabatic process is that process in which heat energy remains constant. Q remains constant. Q constant. If Q remains constant, it means what? dQ is equal to 0. If dQ is equal to 0 means what? ds is equal to dQ by t. It means 0 by 2 is equal to 0. ds is equal to 0 means what? This is isoentropic process. This is isoentropic process. S is constant, means entropy is constant. So what we are asked, and in adiabatic process, what remains constant? Isothermal temperature remains constant. In isothermal, temperature remains constant. In isobaric, what remains constant? Pressure remains constant. Pressure constant. In isoentropic, yes, it is isoentropic, because in adiabatic process, heat energy is constant. It means dQ is equal to 0, and the entropy is related with the heat energy in the form of ds is equal to dq by t. If dq is equal to 0, it means ds is equal to 0. ds is equal to 0, it doesn't mean that s is also 0. S is constant. That's why its differential is 0. So s will be constant. If s is constant, it means its value do not changes. It means it is isoentropic process. Adiabatic process is also known as isoentropic process. In the isochoric process, what is happens? Volume constant. Volume constant. So you must be aware that in isothermal process, temperature remains constant. In isobaric process, pressure remains constant. In isochoric process, volume remains constant. In adiabatic process, what remains constant? Heat energy remains constant, as well as what? Entropy remains constant. During the isothermal process, Boyle's law can be used. During the isobaric process, Charles' law can be used. During the isochoric process, Gay-Lussac's law will be used. And the thermometer, constant gas thermometer, is based on the isochoric process where Gay-Lussac's law is applied. Okay. Now, the constant volume gas thermometer, about what we were discussing earlier. Just constant volume gas thermometer. Constant volume means what? Constant volume means what? Isochoric process. In isochoric process, which law is used? Gay-Lussac's law is used. What is used? Gay-Lussac's law is used. Gay-Lussac's law. Gay-Lussac's law. You study various law related with the gas. Boyle's law, Charles' law, Gay-Lussac's law. You just understand Graham's law, Avogadro's law. These are the various laws. So, constant volume gas. Constant volume gas means what? Isochoric process, and this is Gay-Lussac's law. Is it given? Archimedes principle? No. Boyle's law. Here isothermal process. Isothermal process. Isothermal process. Boyle's law is used in the isothermal process. Isothermal process, T constant. When T is constant, it means what? When T is constant, PV is equal to nRT. T is constant means this is constant. P inversely proportional to V. Okay, this is the Boyle's law. What is Pascal's law? Pascal's law is do not comes in the what you can say. Pascal's law comes in the hydrostatics. It does not comes in the fluid in the gas. Charles' law. In Charles' law, what? Pressure remains constant. Isobaric process. Isobaric process. Isobaric process. But what we have asked, constant volume. This is isochoric process. Gay-Lussac's law. Is it given? No. None of the above. None of the above. If we have to give the answer, what is the correct answer? This will be constant volume means isochoric process, and isochoric process is discussed by the Gay-Lussac's law. By Gay-Lussac's law. When volume remains constant, it means PV is equal to nRT. PV is equal to nRT. When you are treating V as a constant, it means P is directly proportional to T. During the Gay-Lussac's law, what is that? Pressure is directly proportional to the temperature. Pressure is directly proportional to the temperature. Okay. Our next question is that the product of moment of inertia and angular velocity. Moment of inertia is given by I, angular velocity is given by omega. It is like that. It behaves like mass. It behaves like mass, but is not as mass. Okay? In rotation, mass is not considered. Moment of mass or moment of inertia is considered. But we are just using analogy. This is analogous to the mass. This is analogous to the velocity. And what this is? This is linear momentum. This is linear momentum. So by the analogy, you can tell that this is angular momentum. This is what? Angular momentum. This is angular momentum. This is angular momentum. So angular momentum, this is the angular momentum. Torque is what? Tau is equal to R cross F vector. R cross F vector. Force is what? Force is equal to ma, or more exactly you can say that F is equal to dP by dt. Work done is what? Dot product of force and displacement. It is dot product of force and displacement. It is dot product of force and displacement. The average energy of the Planck oscillator. The average energy of the Planck oscillator. It is the average energy of the Planck oscillator is h nu by h e ka power h nu by kt minus 1. E ka power h nu by kt minus 1. It is the average energy of the Planck's oscillator. Planck's oscillator. This concept was given during the explanation of the Luhmer-Pringsheim experiment. Luhmer-Pringsheim experiment was tried to be theoretically explained by many scientists like Wien's law, and they have given Wien's displacement law. And after that, there were some drawbacks in the Wien's displacement law. So Rayleigh-Jeans law give their theory. But both theories, where one theory explains this side, one theory explains this side. and other theory this explains this side. Wien's displacement law is valid for this side and Rayleigh-Jeans law is valid for this side. So there must be some theory that can explain the entire energy curve, that's a black body energy radiation curves. Planck gave his theory, and during that he laid the foundation of the quantum physics. He laid the foundation of what? Quantum physics. In that case, he has treated the radiation as a resonator. He has treated the radiation, black body radiation, as a resonator, and it was the starting point where it was thought that light or radiation can be treated as particle or resonator or oscillator. The average energy associated with that oscillator or resonator is what? H nu by h nu e ka power h nu by kt minus 1. So what is our correct answer? Our correct answer is that. Our correct answer is that. Okay. Now, our next question is that the concept of temperature was introduced by which law? Zeroth law of thermodynamics introduces temperature as a state function. First law of thermodynamics introduces internal energy as a state function. Second law of thermodynamics introduces entropy as a state function. And third law was taken from the Nernst law that was earlier in the domain of the chemistry, but later it was included in the thermodynamics in the physics also. So, zeroth law of thermodynamics introduces the temperature concept, and this temperature concept was given for the equilibrium. The necessary condition for thermal equilibrium is equality of temperature, not equality of heat energy. Okay. The first law of thermodynamics that can be given by dq is equal to du plus dw. dq is equal to du plus dw. Here internal energy. This internal energy is treated as the state function. Internal energy is treated as the state function. Okay. Second law of thermodynamics give the Clausius inequality as like that ds is greater than or equal to 0. It means entropy will never be negative at any case. In any case, entropy of the system will never be negative. The entropy of the entire system, if calculated or measured at the same time, it will be always increasing. So this is given by the Clausius inequality. That is Clausius inequality. Okay. Third law of thermodynamics was earlier referred as the Nernst law. It was referred as Nernst law, and this was that unattainability of 0 Kelvin temperature. Unattainability of 0 Kelvin temperature. Unattainability of what? 0 Kelvin temperature. Okay. Let me confirm that is any problem, because I was not considering the chat box. When I had reported that mother chode and getting him out of the session, that OBS get hanged. Is there any problem? No. So let me move. Just we are confirming your chat box. Yes, we have already told that this session will be completely in the English language. In the thumbnail we have already declared that this session will be in purely English language. In helium-neon laser, population inversion is a very important condition for the production of laser. For the production of laser, what you have the necessary condition for the lasing action. This is known as lasing action. Lasing action is what? Production of laser. You have to consider active medium. You have first active medium. Another is pumping. Proper pumping, excitation source you have to consider. You can consider the optical pumping, you can consider the field pumping or electrical pumping. Active medium, pumping, and the most necessary condition is that population inversion. The most necessary condition is population inversion. And this is associated with the metastable state. Population inversion will occur in that case only where metastable state exists. This is the necessary conditions for the production of the laser. So this question is asking about that helium-neon laser population inversion is achieved with the help of what? With the help of optical pumping. In the ruby laser we use electrical pumping, and in the helium-neon laser we use optical pumping. Pumping is a process in which atoms are excited from the normal state to the what? From the normal state to the excited state. And near the excited state, there exists a metastable state where most of the excited atoms reside here, and suddenly these electrons are brought down in the normal state and the energy is emitted. A very intense light, a very coherent light, a very unidirectional light is emitted, and that we called as the laser. Light amplification by a stimulated emission of what? Radiation. This is the main principle. Our last question is that the shortest wavelength that can be generated by X-ray tube, the shortest wavelength means highest frequency. Shortest wavelength means what? Highest frequency. Shortest wavelength means highest frequency. That can be generated by an X-ray tube depends mainly upon what? That depends upon accelerating voltage. When you what you do, you just take obstacle, target. This should be very hard metals. And electron beam, a fast moving electron beam should strike this. When this fast moving or accelerated electrons get retarded, then an energy comes out, and that energy comes out in the form of X-ray. That energy is come out in the form of X-ray. So accelerating voltage. This is accelerating voltage. These were the 15 questions that we were going to discuss. This is the last question of this session. So we will meet in the next session. In this session, we have already told you that this session will be carried out in purely English language. लेकिन कुछ मादरचोद यहाँ पे भेजे गए थे, एक दो ट्रॉलर जो है भेजे जाते हैं, जो कोई और नहीं होता, टीचर का ही ट्रॉलर होता है। स्टूडेंट तो बेचारे पढ़ते हैं, और जिनको नहीं पढ़ना रहता है वो नॉर्मली बाहर हो जाते हैं। लेकिन कुछ मादरचोद जो रहते हैं, जो टीचर्स के ही वर्ग के लोग होते हैं या टीचर का स्टाफ होता है, वही लोग आकर के यहाँ पे अपना जो है माई और बहन को जो है चदवाने के लिए यहाँ पहुंच जाता है। ठीक है, तो वैसे लोगों को हमको मालूम है किस भाषा में बात करना है, इसलिए स्टूडेंट लोग इसको नेगेटिव नहीं ले। आप एक ग्रेजुएट पर्सन है, ग्रेजुएशन कर चुके हैं, इस सब चीजों को समझते हैं, और ऐसे भी आप आने वाले कल में जो है आप कई सारी जगह पे डील करिएगा जहां पे स्ट्रांग जो है डीलिंग होना चाहिए, चाहे मुंह का हो और चाहे जरूरत पड़े तो ठोक देने का हो। जब ठीक है, किसी भी तरह से स्ट्रांगनेस जो है रखना चाहिए। ठीक है, तो चलिए नेक्स्ट क्लास में हम लोग जो है मिलते हैं, टेक केयर ऑफ दैट।